Good morning and Jai Gurudev students. Today we'll start states of matter. In this, first of all, we have to learn about intermolecular forces. Intermolecular forces. In this one, first point is your London force. Now, if two neutral atom is there, when they come closer, there are electrons on the neutral atoms. When they come closer to one another, then there may happen that for one atom the electron density shift more towards right and this one remains neutral. In that case, what will happen? The electron of this one repel the electron of this one, and electron of this one attracts the positive charge of this one. So both of them become dipolar like that. So in this case, there is a force exists between them. It's called London force. Second point, dipole induced dipole force. In that case, if we have a polar molecule like that, polar molecule means positive charge, negative charge. In front of that, if you have a non-polar molecule, this is non-polar molecule. Now electron of this one repel the electron of this one, and electron of this one attract the positive charge of this one. So after that, one scenario will come where due to its positive negative charge, the next one also develop the positive negative charge. So it is called dipole. This is dipole, induced dipole in this one. Just like that, when a iron blade, the blade made of iron stick with magnet, or iron nails stick with the magnet for overnight, then you will see that iron nails also become magnet. This is called dipole induced dipole. Another force is the dipole force. Dipole force. In this one, a dipolar molecule and another dipolar molecule. There is always a strong force between dipolar molecule. So this is called dipole induced dipole. Another dipole molecule you can draw like that. There is always a force exists between them. This is called dipole induced dipole. After that, student, we have to learn gas laws. There are lots of laws are there. So this is gas laws. In this one, first one is your Boyle's law. In Boyle's law, your volume is inversely proportional to the pressure. For example, if you have a balloon like that, if you increase the pressure outside the balloon, the volume of the balloon decreases. The volume is inversely proportional with the pressure. This is what is called Boyle's law. Or you can tell that volume equal to some constant K into 1 by P which implies PB equal to constant. So that law become P1 V1 is equal to P2 V2. So the law what we've told that become P1 V1 is equal to P2 V2 equal to constant. So graphical representation of this one. Graphical representation in x-axis if you have pressure and y-axis if you have volume. So it will goes like that. So when the pressure increases, volume decreases, or when the volume increases, pressure decreases. This is the graph. Now this type of graph is called your isotherm. Means graph at constant temperature. This type of graph is called isotherm. The graph at constant temperature is called isotherm. Next is your Charles law. In Charles law, it is that volume is directly proportional to temperature. At constant number of moles and pressure. It is obvious that when temperature increases, volume also increases. If you consider the example of popcorn, in popcorn, if you heat that one, the volume increases. If you take the rice, when you heat the rice, then its volume increases. So that volume equal to some constant into temperature, or V by T equal to constant, which implies V1 by T1 is equal to V2 by T2 equal to constant. Actual law is rather different. Actual law tells that if this is the volume of a substance V0 at 0 degree centigrade. Now if I give 1 degree centigrade temperature to that one, its volume is going to increase. Then total volume now become V1, which is V0 plus 1 by 273 into V0. Now if it is increased by a temperature of T, then that become Vt equal to T by 273 into V0. Like that, if I goes and if I tell that temperature is minus 273, then become this V0 minus 273 divided by 273 into V0. This is V0 minus V0, that becomes 0. So in that case, the volume becomes 0. Means a substance does not exist at this temperature. And this minus 273 centigrade at which the volume becomes 0 is called absolute temperature. Although this, for gases, we cannot have that minus 273 degrees centigrade. Before attaining this temperature, the gas become liquid, and liquid cannot be compressed further. So this is what is called Charles law. Charles law is now in terms of graph. We can have that graph for Charles law. Charles law graph is like that. -100°C, 200, 300, -100, -300. This is volume, this is temperature. Now in this graph you can extrapolate at -273°C. Your volume becomes 0. So this is -273°C. Your volume becomes 0. Next is your Gay-Lussac's law. Now in Gay-Lussac's law tells that volume. Now it is a relation between pressure and temperature. Pressure directly proportional to temperature at constant number of moles and volume. Now pressure directly proportional to temperature. Now if you have a cycle tire, now you observe that the cycle tire get punctured more in the summer because pressure is directly proportional to temperature. In summer temperature is high, the kinetic particles that is inside the tire are having more kinetic energy and they pressurize the walls of that one and they get burst. The tires are burst in summer due to Gay-Lussac's law. Another law that you require to know, this is your Avogadro's law. Avogadro's law tells that volume is directly proportional to temperature. Volume directly proportional to temperature, this is Avogadro's law. Volume is directly proportional to number of particles at constant temperature and pressure. So this is your Boyle's law. Means if your number of particles are more, volume is more. If number of particles is less, volume is less. If the number of particles is 6.0 10 to the power 23, then volume is 22.4 liter. If it is 12.044 10 to the power 23, then volume is 24 into 2. 24.4 into 2 is 44.8 liter. So these are the laws. In the next class we'll take rest of the things.